And they're different, dominated by different winds from in different regions. So westerly wind, which way does a westerly wind blow? Which way are the air particles moving in a westerly wind?
East.
Yes, they're moving east. They're blowing from the west. Okay? I think that's probably been like that way for centuries, and they thought we better go with it. At the same time as we're doing this sign, let's design a house here. And I'm going to design a house with a roof. This is looking down. And that's north, that's south, east, and west. And so, depending on this house, if this house was very asymmetric, you might have to consider the westerly wind different from the northerly wind. Okay, we've got to consider all these different actions. Okay, we're going to keep it simple. We've got a sign. The sign could be placed at any orientation. Right? If that sign is placed directly north-south, only a north or a south wind can really blow it hard. Right? So you could ignore the others. We're going to say, look, for the sake of argument, we're not sure if they're going to install the sign this way or this way or this way. So we better take the worst case just in case, right? So let's consider our MD equals 1.0. And that is from table 3.2a. Hope you guys can read this afterwards. All right, so far so good. Okay, now we're up to our MZ cat. So our MZ category takes into account two things. One is the height above the ground and what the terrain is like around it. Okay? So basically the higher up you go, the faster the wind blows. That's because as the wind blows across the ground, there's friction there, it slows down. So this table is all about, it has a height from less than 3 meters all the way up to 200 meters. And it has a factor, which varies from 0.97 all the way up to 1.39. So what is our terrain category? What is the terrain category?
So it's like less than 3 meters? Yeah.
Okay, that's a height. So we'll be good for less than 3 meters. Happy days there. Sorry?
You haven't told us the terrain.
I haven't told you the terrain. Okay. What if we consider a sign out at the place you're doing your lookout thing? Where this project is, right?
Yeah.
What's it called? Peel lookout?
Yeah.
Yeah. What terrain category is that?
2.5.
Yep. Why is that?
Looking at my notes.
Yep.
2's open terrain, grasslands with scattered obstruction. 2.5 is terrain with trees, isolated obstructions, large acre development, fewer than 10 houses per hectare.
Yep. And terrain category 3? Yes, okay. If you're in a well-forested area, you could be in a 3. If there's trees here and trees there, you're more of a 2.5. Sorry? It's a 3 then, it's pretty well-forested. Okay. And is it gonna stay forested for the life of the structure?
Yes, it's nature.
Cool, all right. So let's go for terrain category 3. MZ cat equals, and I look up the table. For terrain category 3, and something less than 0.3, you get 0.83 equals 0.83, and that is H is less than 3, terrain category equals 3, table, table 4.1.
Yeah.
Okay. Now the reason I'm writing all these down is so that when someone checks your calculations, they see you've got this factor, they can find it again to make sure you did it right. Otherwise, it's like a number pulled out of thin air. Where on earth did they get that from?
Now, with all of these things that are in the tables, like from your book,
Yeah.
are they like standards that you use throughout every project, or do you have to sometimes change them depending, or is it like just a set guide that you just go by them?
I guess you go back to the scope and say, what is the scope of this? The scope of this is structures in Australia, under wind that happens in Australia. So if those circumstances are different, then no.
Yeah.
Everything, like I've designed in other countries where we didn't use this, we use something else. But yeah, this is what you're using, being in Australia. Yeah. If you're designing, yeah, that's fine. Yeah. Okay, so we've got MZ. Okay, we've got MZ cat. Let's go MS. What's MS?
Shielding multiplier.
Thank you. MS is a shielding multiplier. If you build a house and it is surrounded pretty well by lots of other houses, then you get to downgrade the wind speed. Shielding multiplier is over here in table 4.2. And if you want to consider shielding, you've got to consider how big is that building beside yours, where is it in relation to it, how far away is it. And there's a bit of formula there. You're not allowed to use trees for shielding because they can get cut down. You've got to consider, is the thing that's shielding your structure going to survive as long as your structure, right? Or not. So things, houses in suburbs, yeah, you get to reduce it. Otherwise, pretty much everything else, shielding is 1.0. And MT is a little bit of a difficult one. MT is what we call topographic multiplier. Don't confuse topographic with terrain. Terrain is about the trees, the obstructions, the roughness of the ground. Topographic is about the hills, okay? Basically, sorry?
Sorry. Which table did you get MS from?
Yeah, good question. 4.2.
Thank you. Sorry.
No, oh, I'm glad you brought it up, thank you. Terrain, topographical multiplier is about the hills. Where you have a flat ground and there's a hill, the wind gets compressed as it goes over the hill. You end up with a higher wind speed over the hills, okay? And that is, there's a couple of formulas for that, a couple of tables for that. That starts at section 4.4 and is in there, and it sort of varies whether it's an isolated hill like that or whether it's an uphill slope and then flat, whether your building is on the front of the hill or on the back of the hill. So remember, of course, that if this wind is blowing west and you've got a house here, it's on the front of the hill, but if that wind is blowing east, then it's on the back of the hill. Okay? This is why you end up with different wind speeds from different directions. So that can be anything from 1 to 1.7, okay? So you can't ignore it completely. If it's on flat ground, it's 1.0. That's happy days. If it's on the top of a cliff, you get to use a table instead of working out a fairly difficult formula. All right? So remember to turn the page for that. And New Zealand has different factors than Australia. Not really sure why. Let's assume that our sign is on the flat ground and we're using MT equals 1.0. And that's clause 4.4. Okay? Flat. Okay, then we add we multiply all those together. So we multiply 41 times 1 times 1 times 1 times 0.83 times 1 times 1. What does it equal? Got a calculator, thanks. 41 times 0.83 in this case.
That's 34.03.
34.03 meters per second. All right. For our sign, this sign up here, our designed wind speed is 34.03 meters per second. Are we all happy with that? Everyone follow how we got this far? Okay, so we've done half of it now, we've worked out the wind speed. There is a little clause in there somewhere, and I've referenced this in the topic, but I can't remember where it is, which says if your wind speed is less than a certain amount, you have to take another value. And I think it's, if it's less than 34 actually, so we're okay here. All right. So we have worked out the wind speed, all right? If you've got a fairly complex building, you'll end up with 8 wind speeds for the 4 and then the 45-degree angles. So you might have a diagram like this, where that is 41, that is 40, this one is 38, and so on and so on, all the way around there. And then you have to work out the actions from all those different load things, all the different directions, okay? Quite often I say to myself, this building that I'm designing, I'm not confident that at a late stage the architect is going to go, you know what, let's have it this way around, okay? So the conservative thing to do is to pick the worst one and design that all the way around. Be careful with always taking the conservative option, because those conservative things add up until you've very over-designed something, all right? But that one, you're definitely going to sleep at night, okay? Does that make sense about conservatism?
Yeah.
Yep.
Okay. Oh dear. Try again. All right. Okay, let's push this up. We have V. Now we have the wind speed. Now let's work out what that wind does. And there's a formula I'm looking for to turn that into a pressure. Anyone know where that is?